Hi, and welcome to Calculus Examples. I'm Dr. Finch. Today we're going to look at an example where we're finding the volume of a solid described by y is equal to x, y is equal to square root of x, and it's rotated about the line y is equal to 1. We see the picture here. I'm going to actually shade in. This is the bit that's going to be rotated around y is equal to 1. So we're rotating around that line right there. It's going to look a little bit weird, but what we're going to do is we're going to chop that up and add it up the way we do for volumes. Notice when we rotate that around the line, the shape that we're going to get is going to be kind of like a washer. And please excuse my drawings here. They aren't the best. There's my washer with a little bit of a there we go. We've got a change of x that's going on here when we chop it up because even though I put my lines in the wrong direction, we are chopping it up on our x-axis like this. So we're going to have washers as we move this about. When you are dealing with washers, remember, we're going to look for the volume of our washer, and that is going to be about pi times the outer radius squared, because we're looking at a circle and pi r squared is the area of a circle, minus pi times the inner radius squared. And to make sure that this has a volume to it, because I said pi r squared is the area of a circle, notice we also have this change of x. That's going to give us just that little bit of depth. So we are going to multiply that by change of x, and that is what's going to give us our volume when we put this all together. So there's two pieces of information that we need here. The first is going to be the outer radius, and then the second is the inner radius. All right. To figure these out, I want to actually scroll up to our picture here. Our outer radius is going to be, notice we are taking our line, and I'm just going to do, let's see, I'll do this. We are going from all the way to the top to our line y is equal to x. So this is going to end up being 1 minus y, which is the same thing as 1 minus x, right? So either way, however you want to think about it, um, because we are starting at 1, and then we are taking away this distance here, whatever that distance is, and it's going to change as we move along x. So 1 minus x is going to be our outer radius. Our inner radius, on the other hand, is going to start at the top, but it's only going to go down to our square root of x function there. So our inner radius is 1 minus the square root of x. So that's going to be the inner radius we're working with. Let's rewrite our volume washer. And I put the little w on there to remind ourselves we're looking at a washer type function. Pi 1 minus x squared minus pi 1 minus square root of x, quantity squared, change of x. All right, next step up is to turn this into an actual volume. Because we've got a pi in both of these slots right here, I'm going to yank that all the way out of our function because we can do that. We also know that where is a square root of x? Where is this point where these two functions meet? That's going to be when square root of x is equal to x. In other words, x is equal to 1. The other place is obviously x is equal to 0. So we're going from 0 to 1, and we have 1 minus x quantity squared minus 1 minus square root of x quantity squared. And that change of x is going to turn into a dx for our function here. Let's start calculating it. So let's square this out. This is going to be 1 minus 2x minus x squared, or plus x squared, minus, and I'm going to keep the parentheses around this to begin with, and then we'll get rid of it in just a bit, plus square root of x times square root of x is just a regular x. All right, let's take care of those parentheses. So we are just distributing that negative sign throughout. We want that dx there. Our ones are going to cancel on this. And then we are going to be able to put some things together. Let me add in that x squared there. So now we've got pi from 0 to 1. And this is going to give us, let's see, we've got a negative 2x and a minus x. So minus 3x plus x squared plus 2. And I'm going to take that square root of x and turn it into x to the 1/2 dx. All right, I always like to do that. We want to change our square roots so that when we take the antiderivative it, we know how to work with that very nicely. We're going to go to the next page and let's move on. So now we're ready to take our antiderivative. We have negative, add 1 to our power, divide by our new power, so that's 3/2, plus add 1 to our power, divided by our new power, 1/3, plus 2, add 1 to our power, so 1/2 turns into 3/2. And there's two different ways we can talk about this. We can divide by our new fraction, which if we do that, we're going to be dividing by 3/2. The other thing to think about here is that you can just multiply by the reciprocal is the other way to think of that. So I'm actually going to cancel this out and write it as multiplying by 2/3 instead, because that is going to make it so much easier to work with. And we are evaluating from 0 to 1. All right. So once we have that, plugging in 0, everything's going to cancel. Plugging in 1, we get negative 3/2 plus 1/3 plus 4/3. So this is going to give us pi negative 3/2 plus 5/3. Next thing is we need a common denominator to add our two fractions. So we are going to multiply by 3 on our numerator and denominator. Whoops, 6 on our first fraction and by 2 on our second fraction. So we end up with 10 minus 9, or negative 9 plus 10 over 6. So this is going to give us pi times 1/6, or you can write it as pi divided by 6. And there's the volume of the shape that we created. Thank you for listening.